Hello, and welcome to my talk. I'm Mikhail from Spotify. So this talk is named How I Learned to Stop Worrying and Love Gradle. So it's apparently about popular and widely used build system named Gradle. The name of the talk is reference to the Stanley Kubrick movie Dr. Strangelove, my personally one of the favorite directors. So the talk is more about how Google forced us to switch to Gradle 2 years ago, 2 years ago in 2013, and how we basically pretty much happy living in this whole new world. Before I start, who I am, I'm Mikhail. I am originally from Russia, so moved to Sweden 2.5 years ago. I'm working in Spotify in Android land. I started with a clear focus on improving our testing framework to basically create a framework to run functional tests on the mobile devices. Today I have more shifted to our automator in general. So I'm working in the team. We own releasing pipeline. We maintain our old test frameworks.
Put it down, the remote presenter. Yeah, it's interfering with microphone.
Okay. So before I started in an Android team, I was a backend Java developer for 8 years. So this is a small plan for today. I will start with the small overview of our process and our core beliefs regarding continuous delivery. So, and I will spend some time on basically inventory of the things which we managed to automate with Gradle. So it's not really a hardcore presentation. It will be no line of Gradle code. So yeah, like official building. Yeah, we moved to Gradle from what? Basically, before Google started officially switched to Gradle, it was some sort of Ant scripts. Like it was, I think, basically based on Ant, Apache Ant. It was not good. So I'm working in Spotify, and Spotify is a very popular music streaming service, and I really hope you heard about it. At least in Sweden, it's hard to find a person who never heard about Spotify. So we are pretty big. I think 1,500, and half of us is actually working in the technology department, which is developing product. We are pretty aggressive in hiring even now, so I think we would have something about 200 open positions until end of the year. But speaking about Spotify, Spotify is just a software company which wants to make some code changes and deliver to end users. And this problem is not new at all. It was there even before Spotify was born. It will be after. Basically, previously, we didn't, the world back then was not quite the same as we see it now. We didn't have a mechanism for seamless and background updates as we do have now. It basically forced developers to think in terms of big projects and ship rarely. But today, the cost of updates significantly decreased. So Google Chrome ships every new version in a few weeks, every couple of weeks. As soon as you close your browser, it will install a new version. Facebook, they ship every 2 weeks. For example, if you have iPhone, every 2 weeks, Facebook will download 100 megabytes updates as soon as you connect your charger. And whenever you hear about continuous delivery first time, it could be a bit counterintuitive. But to have less painful releases, you basically need to release more often to avoid the pain. So this path to have often releases is basically this path was a lot of companies choose this path. We know for sure that Google, Facebook, Twitter, Dropbox, and many other companies now ship on a regular basis. I think Facebook and Twitter has 2 weeks release cycle, and the same as Spotify. So I will be talking from an Android perspective. So all numbers are from Android land, but it's pretty much the same for iOS and desktop. So we have about 30 developers in Android. So we contributing to the same repo. So we sit in 4 offices in 3 time zones. So it's Stockholm, New York, and San Francisco. So somewhere here, it's actually 2015. I couldn't. Anyway, so we start really growing too fast, and a lot of things starts breaking up. So our process was not nice and shiny as we have it now. So we learned in hard way a couple of things which I want to share today. So the lesson number 1 is if you want to release often and in time, feature branches doesn't work. In many projects, it's very common to branch your code base to develop a new functionality. And the idea here is that you will temporarily, because the new code can temporarily destabilize your project, and it will affect users and other developers. So you develop it on feature branch, and next you merge it to master, and next it comes some period of instability where you will fix all these integration issues. So, but we can't really accept a huge chunks of new changes landed to master, because we want to ship often, and some of the channels ships every day. So we cannot really take down some of our channels. For example, employee ships every night. Employee channel ships every night. From another hand, the master branch, if you have a lot of developers, master branch moves really quick too. So, and if you be isolated working on a feature branch, it's not really practical for you, because it would be too much of rebasing and a lot of problems when you try to merge it back. So what we do instead, as soon as we're ready to ship, basically every 2 weeks, we create a release branch where there is no active development and only critical bugs will be fixed on this branch. So right now, on average, we have about 15 pull requests to release branches. So basically 15 pull requests per release. But we put a lot of efforts to decrease this number down to 0. So lesson number 2, if you want to move faster, consider to use one repository. So because of a lot of historical reasons, we are not there. But we have just a few repos. So we have one per platform, Android, iOS, desktop, and one for cross-platform shared library, native library called core. The same principle here as we have for feature branches. The core is developed really fast too, so we have a lot of changes coming to core every day, and we cannot really accept land to too many changes in core to the master, because it will destabilize master branch for days. So what we do instead, as soon as someone commits to core, we try to build together the latest version of core to run all available functional tests, and if everything is green, we will create a commit which will bump core to the latest. And we do it for every commit on core. And clearly it would be much easier if we would have a one repo. To release often, so basically the lesson number 3, do have short release cycle and do have multiple channels of distribution. So we right now at this point have stable channel where we ship every 2 weeks. Plus, we have employee channel where we do nightly releases. For iOS, we ship every commit, I guess. There is also a partner channel, there is a beta channel, there is an alpha channel, there are a lot of different channels. And the thing here that if you have a multiple channels, it will basically force you to think about automation. So it would be, if you have some manual step in your releasing pipeline, it would be first time consuming because you need to get out of the flow to basically do some manual step. Even if it's just to run a script which takes you 5 seconds, you still like interrupt you get out of the flow, and this context switching couldn't be really good for you. Secondly, it's error prone. If you have manual steps, we learn the hard way that humans are humans. It could be mistakes, wrong button pushed, whatever could happen. So we start thinking about automating all the possible things in our releasing pipeline. But the problem was that back then we used a old build system which was patched by our custom scripts. It was a huge mess of different scripts written in Python, Shell, and even Ruby. And basically it was wrapped into the Ant, which was by the time official Google's build system to build Android. Fortunately for us, we were not only company who was suffering from their obsolete build system. Google, on a major event in the Google major event, Google I/O, in 2015, they announced support for new build system. And in practice, Google actually built a huge plugin for Gradle to be able to build Android clients. So Gradle was quite a while already. Gradle was existing quite a while in 2015. So a lot of open source projects chose Gradle as a primary build tool. I think Spring, Hibernate, Play framework, if you are working with the web, all of them were using Gradle by that time. So one of the main benefits of Gradle is that Gradle build scripts, they are clearly expressed intention. So the scripts become very concise and readable, mostly because of they are not using XML. They're using Groovy instead. So the build script is basically a small program. Secondly, Gradle is heavily inspired by philosophy of build by convention. So or prefer convention over configuration. So if you have a Java project and you okay the defaults, so the build script for you will be one line. And it took us a while to basically to switch from what we have back then to the Gradle, because I already mentioned it was a mess of different build scripts, but we finally implemented and started moving further. And as I mentioned in agenda, I will go through some like major things which we managed to automate with Gradle. And like any development starts on a developer local machine. So, and basically Gradle is really good in supporting different flows. It's not like Maven install for everyone. It's so you basically can really distinguish. So here's developer machine. I will be running those, and those tasks. I will be good in incremental builds. I will build only that things. And if you're talking about continuous integration server, so you basically less affected by time sometimes, so you can run more, you can build more. And so as I told, the journey of code change starts on a local machine of developer. And one of the amazing features of Gradle is a Gradle wrapper. This is a small executable file which you will commit to the root of the project. And basically this small executable will know how to download the latest version, so not the latest, but the specified version of Gradle to build your project. And this is actually a really great idea, because in this case you don't need to install Gradle globally as you do it for Apache Ant or Maven. You basically can use a different version of Gradle for different projects, or even you can use a different version of Gradle on the different branches. So for example, like if I going back in time and want to like check out Spotify client, the version which is 1 year older, it's still using Gradle, but the older version, and I'd still be, I don't need to install it globally, so I will just type Gradle W assemble and it would work. From another hand, this actually allows the Gradle, the product, moves faster, so they know that changing in a DSL or changing in a way it works doesn't really affect developers. So because of they still can be compatible with older versions, so they don't really afraid to change a lot of things. Secondly, the dependency management. This is the thing you expect be solved by build systems. If you write a project, and most likely it would have some external dependencies. Most likely, if you do web development, it would be like maybe Spring, Play framework. If you do Android development, you would probably use some Square open source libraries. And Java itself doesn't provide a mechanism for dependency management, but the problem is pretty old and successfully solved by predecessor of Gradle. So Maven have a declarative dependency management, and this model was successfully adopted by Gradle. So they didn't invent the wheel. So they just like they adopt dependency management from Maven and made it slightly better. So it works interoperably with Maven repositories. It also supports all kind of any weird stuff you can come up with, and if you even have a really weird dependency, so maybe comes from some weird server, so you can implement it by your own. So Gradle popularity was growing, and a lot of players on the IDE market came to the game. So they provide a first-class support for Gradle. So Android Studio, IntelliJ, Eclipse, Sublime, Atom, you name it. All of them have a decent Gradle support. I used the word decent because I couldn't really say it's great support, because usually the Gradle provides you ability to create really complex project, multi-module projects, and the complexity of those can really decrease performance of IDE. So, and also we've seen a lot of regressions in the Gradle support. So in Android Studio, the mostly we use. And there are two learnings here. The one is those things are really under active development. So and it's actually get improved through the year significantly. The second learning is that the way Gradle integrates with IDEs is implemented using plugins, and in really worst case scenario, you can monkey patch the configuration files of IDE, and we did a couple of times. As soon as developer says the change is ready, so the change is actually travels to continuous integration server where it will be tested. So we want to provide feedback on the change, so we want to run all possible static checks. We want to run as many tests as we can. So in practice, having a monolithic build is not really good for feedback time. So At some point we decided to have an upper bound for feedback time within 10 minutes for developers. So, and basically it forced us to split our monolithic build into smaller ones. And as soon as one of these small parts reach the 10 minutes, we will consider to optimize it or break it down more. At this point, we used TeamCity, and TeamCity will trigger 9 different builds for change in Android. It's 3 builds for static analysis, 3 different configurations for testing, functional tests and unit tests, and other builds will compile client for different platforms, for different architectures. As a comparison, the shared library core, which is a native part of Spotify, they firing up 25 builds, which it is basically because they have more different any kind of tests, and they have to support more platforms. So the things we solved with Gradle, the one thing you don't really consider when you do local development is versioning. Gradle Android platform has a really strict policy on versioning, so the platform itself not allowing you to downgrade application. Also, if you have and it's getting more complicated when you have multiple channels of distributions. So because beta build could not be less than stable build, and so on and so forth. Testing. So this is a test pyramid. This basically says there is like considerable, there is a sensible proportion between different types of testing. So we like unit tests, those are easy to write and really fast to run, and you should consider to write them more. UI testing is usually hard, and you should avoid it by any means. But the good part that Gradle is totally agnostic to the types of testing. You can basically come up with any insane amount of testing types. You can create a huge graph of testing tasks, create crazy dependency between them, and it would still work. From another hand, Gradle support JUnit, TestNG, and some other common tools out of the box. And there are a lot of plugins. If you use some like coverage, or you're talking to Sonar, or there are a lot of integrations you can find. They have a hub for plugins, and you can find probably all of them. So the thing that hardware is getting cheaper and cheaper, and nowadays it's very common that your developer machine would probably have 4 or 8 cores, and it's rather important that build system knows how to utilize all available resources, and it's especially important on the continuous integration servers. So Gradle has a built-in support for parallel execution. So if you have a multiple module project and there is some decoupled modules which are not dependent on each other, Gradle knows how to build them in parallel. So basically have a dedicated core to build module in a parallel. So the change, get the feedback, all tests are green, we can merge it, we run more tests, we run more checks, and as soon as we can deploy our current master to some of selected channel. So we're not only deploying like Android client. As soon as your project grow, it could be some third-party dependencies where you basically they transform your delivery pipeline. As one of example for us, it's Crashlytics. This is a service, the third-party service, which we use to report crashes from user phones. Basically, the crash itself doesn't contain enough information to be decrypted. So if it's a native crash, we don't run binary with symbols. It doesn't contain symbol information. If it's a Java, we run it through obfuscation. So like Crashlytics needs to know, like we need to upload them mapping file to know how to decrypt crash. And fortunately for us, Gradle is so popular that Crashlytics is basically provide us a plugin to integrate into our delivering pipeline. So basically, we don't need to worry about when mapping files get uploaded to the Crashlytics servers, because it happens in the Gradle plugin. And I think it's actually really cool when you have an integration with a third-party library, but it doesn't come not only with a jar which you compile into your binary. It comes into the Gradle plugin, which seamlessly integrated in your building pipeline. And this is the final step for at least for us. So you deploy your change to Google Play, where it will, like, as soon as you deploy a binary, it will be accessible for millions of users. It's still worth to mention that we have quite a lot of different build types and different flavors. So basically, we have a build for beta, for partners, for employees. We have a debug, we have release, and this should be multiplied by amount of architectures we support, x86 and ARM. And we have different channels, like we have a stable where it goes out for all users. We have a beta, alpha, and we have a nightly channel for employees. And basically, Gradle provides really nice mechanism of how you bind those all together. So Gradle is quite popular tool, and like if you really want to start, I intentionally didn't put any Gradle in my presentation because I think those things can do better. So there are quite a lot of books on Gradle. I highly recommend Gradle in action, and if you just get started, if like your continuous delivery, the second book is more or less recipe, how you can be more productive with Gradle, how you can create plugins and so on. And Gradle itself moves really quick, so I kind of expect those books can be obsolete in 2 years. But the good side that they have a really good documentation on the website. It's really, really good documentation, and it's always up to date. It's cross-referenced with the auto-generated part of the Gradle, and Gradle is open source. So if you're really stuck, you can go to sources. It's on GitHub. It's super easy and really nice code, by the way. As a conclusion, I have the Gradle motto. This is basically what's the people who create Gradle things. Make the impossible possible, make the possible easy, make the easy elegant. And that's it, what I have.